This is an example of solving a quadratic equation by completing the square. Our equation is 3x squared plus 4x minus 5 equals 0. Remember, in order to use completing the square, we must have an a value of 1. That means the leading coefficient in front of x squared has to be a 1. In this example, our leading coefficient is 3. We're going to divide everything by 3 to create a leading coefficient of 1. Dividing everything by 3 gives us x squared plus 4/3 x minus 5/3 equals 0. Now that we have a leading coefficient of 1, we're ready to move on. Next, we're going to move our constant term to the other side of our equation. Our constant term is negative 5/3, so we're going to add that to move it to the other side. Okay, we're ready to add something to both sides to complete the square. Remember that the goal of completing the square is to create a perfect square trinomial. To find the number that we should add to both sides, we need to do some scratch work. We want to take half of b and square it. b over 2 squared. In this example, our b value is 4/3. That's the number, the coefficient in front of x. So let's put 4/3 in place of b. That gives us 4/3 divided by 2 squared. Now, instead of dividing by 2, let's think of this as multiplying by the reciprocal of 2. This will look a little better. So we're going to multiply by the reciprocal of 2, which would be a 1/2. Let's multiply our fractions together. 4/3 times 1/2 gives us 4/6. Before we apply our exponent, let's see if we can reduce this fraction. 4/6 would be the same as 2/3. And then finally, when we square that, 2 squared is 4, 3 squared is 9. That gives us the fraction 4/9. This is the number that's going to help us create that perfect square. Okay, let's go back to our equation and let's add 4/9 to both sides of our equation. Remember, whatever you do to one side of an equation, you must do to the other. Okay, next, let's think about factoring the left-hand side. The goal of completing the square is to create a perfect square trinomial, so when we factor the left-hand side, it should look pretty. It should turn out nice. Also in this step, we need to combine these fractions on the other side of the equal sign. Remember, to add fractions, you need a common denominator. We've got 5/3 plus 4/9, so a good common denominator would be 9. Let's rewrite 5/3 as 15/9. Now that we have that common denominator, we can add these fractions together. 15/9 plus 4/9 becomes 19/9. Okay, back to the left-hand side again. We want to factor this, and it's going to be a perfect square if we factor it correctly. So we need to pick two numbers that will multiply together to be x squared. Let's choose x and x. Then we need two numbers that will multiply together to be 4/9. Now that sounds kind of tricky, but we can tell these two numbers are definitely going to have to be fractions. And then let's break it down. Look just at the numerator first. Let's find two numbers that will multiply together to be a 4. 2 and 2. And then look at the denominator. Let's find two numbers that will multiply together to be 9. That would be 3 times 3. Now we just need our signs. They're both going to be positive to give us a positive product and a positive sum when we multiply it back out. Okay, notice it is a perfect square. We have two identical factors, x plus 2/3 times x plus 2/3. Since it's being multiplied by itself, we can really rewrite this. The left-hand side can be x plus 2/3 squared. That's what it means to multiply something by itself. From here, we're going to finish solving using the square root property. That means we're going to take the square root of both sides. When you take the square root of both sides using the square root property, also remember that we need a plus or minus sign. We took the square root of both sides to undo this exponent of 2. So on the left-hand side, the square root and the exponent of 2 will cancel each other out, leaving us with just x plus 2/3. On the right-hand side, I want to simplify this square root And I'm going to simplify the square root by breaking up that fraction into the square root of 19 over the square root of 9. I'm doing that because on the bottom, the square root of 9 becomes a 3. Look at these two fractions. They both have a denominator of 3. So that means as my last step, I can combine these two fractions to get x equals -2 plus or minus the square root of 19 all divided by 3. This is our solution.